Hi everyone, this is volume of a cone at a sand and gravel plant. Sand is falling of a conveyor off a conveyor, so it's two F's here, and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude, which is actually the height. At what rate is the height of the pile changing when the pile is 15 feet high? So, first of all, the volume of a cone is 1/3 pi r squared h. Now, our altitude is the diameter of the base. So the radius is going to be 2, the diameter is 2 times the radius. So we know that 2r equals 3 times the height, or the altitude, which is the same thing. So r equals 3/2 times h. Now, I'm going to plug this back in the formula, and what I'll get is my volume equals 1/3 times pi. And again, I keep moving this over. Let's move this over a little bit more. Volume is 1/3 pi times r. My r is 3/2h squared times height. So that means my volume is going to be 1/3 pi 9/4 h squared, because that's your r, so I'm just plugging that in, times h, which is going to equal, I'll do it on the next slide, so that means the volume is going to equal 3 pi over 4 times h cubed. Alright, now all we have to do is take the derivative of the volume with respect to time. So that's going to be, let's see. With the derivative of the volume with respect to time is 10. They already gave that to you. So basically what we're going to do is write derivative of the volume with respect to time equals 9 pi over 4 h squared times the derivative of our height with respect to time, because we're trying to solve for the derivative of h with respect to time. So if I rewrite this, I'm going to flip this around, and so I'm going to have derivative of h with respect to time equals, the 4 is going to go on top, and then we're going to have 9 on the bottom, pi h squared times derivative of v with respect to time, which we already know this equals 10. So I did a bunch of videos where you're just practicing moving this around. So I'm trying to solve for this. So I just flip this over and it's cross multiplying. So now all we have to do is plug in our values when h is 15. So we have derivative of h with respect to time equals 4 times h over 4 over 9 pi times h squared times the derivative of the volume with respect to time. We know this equals 10, and we know h is 15. So this is going to be 4 over 9 pi times 15 squared times 10, which if you reduce this gives you 8 over 405 pi feet per minute. And that's all. Thank you. Have a nice day. Bye-bye.